Wind moves through dry grass. Somewhere close, something is watching. A figure stands at the edge of a shrinking waterhole. The mud is cracked. The air smells of dust and drought. Behind those tall grasses, a big cat is timing its approach. The way predators have always timed their approach against anything that walks upright and slow. This is Africa, close to 2 million years ago. And the creature standing at the waterline is about to make a decision that no human ancestor before it has ever had to make. Stay and starve as the water disappears, or walk into land it has never seen, toward danger it cannot predict, for a chance it cannot guarantee.
It walks. That single decision, repeated by countless individuals across almost incomprehensible time, is the beginning of one of the strangest success stories in the history of life on Earth. Because this species will not just survive one drought, or one predator, or one bad season. It will go on existing in some form across ice ages and warm periods, across continents, across nearly 2 million years. To put that in perspective, all of recorded human history, every pyramid, every empire, every war we've ever read about in a book, fits inside a sliver of time this small. Ancient Egypt is a memory compared to this. Rome is barely
And yet, almost everyone watching this has never heard the full story of how it survived that long. This is Homo Erectus, not the strongest human species that ever lived. Not the smartest, at least not by the ways we usually measure intelligence. But possibly the most successful survivor our family tree has ever produced. The question is simple, and it will take the rest of this film to answer it properly. How does a species outlast almost every environment, every predator, and every other kind of human that Earth ever threw at it? And then, after all of that, still disappear?
To understand what made Homo erectus different, you first have to understand the world it was born into. Africa, roughly 2.5 million years ago, was not a stable place. The climate was shifting, drying, then wetting, then drying again, over cycles that unfolded across tens of thousands of years. Forests were retreating in places. Grasslands were spreading. And every time the landscape changed, the animals living in it were forced to change with it, or vanish. Earlier hominins, small-brained, comparatively short, still partly built for climbing trees, were living through this instability. Their world was crowded with competition. Other primates, saber-toothed predators, scavenging hyenas capable of cracking bone. Food was unpredictable. A body built primarily for the forest canopy was a body poorly suited to an increasingly open, exposed grassland. In the fossil record, something begins to shift. Around 2 million years ago, a new kind of hominid begins to appear in the fossil record, one showing a body plan increasingly distinct from earlier hominids, with features that would become increasingly familiar in later humans. Longer legs, and a body adapted increasingly for life on the ground. Compared with earlier hominids, Homo erectus had proportions that allowed more efficient walking across open landscapes, reducing dependence on climbing and increasing the ability to travel over greater distances. Over time, a larger brain than any hominid before it. Reduced adaptations for climbing, which meant something significant. This creature was betting its survival on the ground, in the open, rather than in the relative safety of the trees. Some scientists debate exactly where to draw the species lines in this period. Some researchers use the name Homo ergaster for early African populations, reserving Homo erectus more strictly for populations that appear slightly later or further east. For clarity, we'll use Homo erectus as the umbrella name for this evolutionary story, the way most popular science does. But it's worth knowing that the fine details of this family tree are still argued over in academic journals today. What is much clearer is the overall pattern. Evolution was producing a hominin increasingly adapted for movement across changing landscapes. And a body meant to move was about to do something unprecedented in the story of our ancestors. It was about to leave Africa.
By around 1.8 million years ago, early Homo had already spread beyond Africa. For millions of years, our lineage stayed close to the environments it evolved in. Then, sometime around 1.8 million years ago, that changed. One of the clearest windows into this early expansion comes from Dmanisi in modern-day Georgia, at the crossroads between Africa, Europe, and Asia. There, buried near an ancient medieval fortress, archaeologists uncovered something extraordinary. Skulls and bones of early Homo dated to close to 1.8 million years old. Among the most striking finds is an elderly individual who had lost nearly all their teeth long before death, meaning they survived for a significant stretch of time afterward. Someone or some group likely helped that person eat. It's one of the earliest hints in the human story that survival was becoming a shared project, not just an individual one. A thread we'll return to.
Dmanisi tells us Homo erectus, or a very close relative, had already pushed thousands of kilometers beyond Africa remarkably early. And the story doesn't stop there. Over the following hundreds of thousands of years, populations connected to Homo erectus turn up across an enormous stretch of Asia, from the Levant through South and Southeast Asia into China and eventually the islands of Indonesia. Picture what that actually meant. No maps, no agriculture, no cities or stored food reserves. Survival depended on reading landscapes, remembering resources, following animals, and carrying knowledge from one generation to the next. Just a body, a small stone toolkit, a social group, and generations of accumulated knowledge about how to read a landscape. This was not one dramatic journey by a single group of explorers. It was a slow expansion that unfolded across countless generations. It almost certainly unfolded the way most evolutionary migrations do, slowly, unevenly, across dozens or hundreds of generations. A group pushes slightly further along a river valley because the last valley ran dry. Their children push further still. Multiply that pattern across tens of thousands of years, and a species that began on one continent ends up scattered across three. Along the way, the environments themselves kept shifting under their feet. African savanna gave way to Levantine scrubland, then to the river valleys and monsoon forests of South Asia, then to entirely unfamiliar terrain in the east. Different plants, different predators, different seasons, different everything. So the question the fossils force us to ask is this: what kind of creature can walk into that many different worlds and keep finding a way to live in each one? The evidence increasingly points to one answer. Not raw strength, not superior weapons. Something quieter, and in the long run, far more powerful. The ability to adapt to new environments, generation after generation, while carrying forward the traits that made survival possible. Before we go further into where Homo erectus went, it's worth understanding what let them go there at all. Because the body itself was doing a kind of work most of us never think about. Compared to earlier hominins, Homo erectus had longer legs relative to their arms, a narrower pelvis suited for efficient bipedal walking, and a body plan that put less energy into climbing and more into covering distance. Researchers who study human locomotion argue that this anatomy made walking and possibly sustained movement over long distances significantly more energy efficient than it would have been for earlier hominins.
Some scientists have gone further, proposing that Homo erectus may have been capable of a form of endurance movement across open terrain that few other animals can match. Humans, unlike most four-legged predators, cool themselves efficiently by sweating rather than panting, which theoretically allows sustained activity in heat that would exhaust many other species. This has led to an influential but still debated hypothesis that early humans may have been able to pursue prey animals over very long distances in punishing heat, not through speed, but through sheer persistence until the animal collapsed from exhaustion. It's an appealing story, and it isn't without supporting evidence, but it remains a hypothesis, not a settled fact. We don't have a recording of it happening. What we have is a body that looks built for it, and reasonable scientific disagreement about how often or how significantly it was actually used that way.
What's far less controversial is the broader point. This was a body optimized for range, for crossing distance, for finding the next waterhole, the next herd, the next opportunity when the current patch of land stopped providing. In a world where climates and landscapes never stayed still for long, a body built to keep moving wasn't just an advantage, it may have been the whole strategy.
A body alone doesn't process a carcass, or fell a sapling, or cut through hide. For that, Homo erectus relied on stone. The earliest and simplest stone tool tradition in the archaeological record, known as Oldowan technology, predates Homo erectus and consists of straightforward, sharp flakes struck from a stone core. Effective, but relatively crude. Somewhere around 1.7 to 1.6 million years ago, something more sophisticated appears alongside Homo erectus and closely related populations, the Acheulean toolkit, defined by its signature piece, the Handaxe, a symmetrical, teardrop-shaped tool worked on both faces, requiring real planning and skill to produce.
A well-made hand axe wasn't a single-purpose object. Evidence and experimental archaeology suggest it could butcher an animal, work wood, cut plant material, and process hides. A genuine multi-tool, thousands of years before that word existed. And here's where the story gets strange. The Acheulean hand axe, once it appears, barely changes for well over 1 million years. Across enormous distances, across wildly different environments, and generations beyond counting, that same basic tool design persists, largely unaltered.
To modernize, trained on a world where technology reinvents itself every few years, that can look like stagnation, like a species that simply stopped innovating. But consider the alternative reading. Maybe that stability doesn't mean an absence of intelligence. Maybe it means Homo erectus had arrived at a design that simply worked, reliably, across radically different circumstances, and saw no urgent reason to abandon it. A tool that still functions after 1 million years isn't necessarily a sign of a mind that stopped thinking. It might be a sign of a mind that got something right the first time. Now picture the world without daylight. No streetlights, no walls, just open darkness, the kind that swallows sound and distance alike. And somewhere out in it, the low, patient movement of predators that see far better at night than any human ever could. For most of the human story, night was simply something you endured. Then, at some point, that changed. The archaeological evidence for controlled fire is genuinely difficult, and scientists deliberately difficult, about overstating it. Burned bone and sediment showing signs of heat appear at some sites associated with early Homo and go back a very long way. But proving that a fire was deliberately built and controlled rather than a natural wildfire that happened to pass through a site is remarkably hard to do with ancient, disturbed evidence. The strongest, least ambiguous evidence for habitual, repeated fire use, hearths reused again and again in the same location, comes from significantly later sites, generally associated with later human populations, though some researchers argue for much earlier habitual use among Homo erectus specifically. This remains one of the more actively debated corners of paleoanthropology. What isn't debated is what controlled fire would have meant whenever it truly arrived. Warmth in cold nights and cooler climates, a defense against predators that otherwise ruled the darkness, light to extend the day, a gathering point for a group, a place to sit together after the sun went down. Some researchers have also proposed what's known as the cooking hypothesis, the idea that cooking food, by making it easier to chew and digest, could have freed up energy that helped fuel the evolution of a larger brain. It's an influential idea, championed by respected scientists. It's also contested and far from proven as the single cause of any specific evolutionary change.
But strip away the disputed dates and the competing hypotheses, one image remains. One that needs no citation to feel true. Humans gather in a circle of light while the dark presses in around them, undefeated, but for the moment, held back. For a species defined by movement and often hostile places, fire, whenever it truly became a habitual companion, would have been one of the most powerful tools of all. Not a weapon, a boundary between danger and safety, drawn in light.
So far, this has been a story of bodies and tools. But the deeper you look into Homo erectus, the more the real story starts to look like a story about other people. Return to Dmanisi and that elderly, nearly toothless individual. Chewing tough, unprocessed food without molars is close to impossible. For that person to have lived on for what may have been years after losing their teeth, someone was likely softening food for them, or sharing it, or simply making space for a member of the group who could no longer fully provide for themselves. Researchers who study the site have pointed to this as some of the earliest suggestive evidence of care extended toward a vulnerable individual in the human lineage. Though, as with much from this period, it's an interpretation drawn from a single skeleton, not a certainty.
Widen the lens, and a broader pattern of likely cooperation emerges across the Homo erectus record. Evidence consistent with shared access to butchered carcasses at some sites, the kind of coordinated movement across landscapes that foraging in unfamiliar terrain would have required, and the simple, unavoidable fact that raising human children, slow to mature, dependent for years, has never been something one individual manages alone. None of this means Homo erectus had modern families, or specific social roles we could name with confidence. The evidence doesn't stretch that far, and it would be dishonest storytelling to pretend it did. But it does suggest something meaningful was shifting. In a world of predators, scarcity, and unfamiliar terrain, individual strength alone was never going to be enough for very long for anyone. For maybe the first time in the story of our ancestors, survival was starting to belong not to the strongest single body in the group, it was starting to belong to the group itself. Here is where the true scale of this species starts to become almost impossible to hold in your head. Homo erectus, or populations closely tied to it, persisted for an extraordinary length of time. The exact boundaries are debated, tangled up in questions of classification and dating. But estimates for the species' existence commonly range well beyond 1 million years, and by some counts, approach nearly 2 million. During that span, the world did not sit still, not even once. Ice ages advanced and retreated. Grasslands swallowed forests, then lost ground to them again. Rivers changed course. Whole animal communities that Homo erectus depended on for food shifted, migrated, or vanished, replaced by others. Try to hold that time scale next to something familiar. all of recorded human civilization, writing, cities, empires, everything from ancient Sumer to right now, spans roughly 5,000 years. Ancient Egypt civilization, one of the longest continuous cultures we know of, lasted about 3,000 years before it changed beyond recognition. Multiply that by hundreds, and you begin to approach how long some form of Homo erectus endured. Across all of that time, across that many transformations of the world around them, they kept finding a way to keep living in it. Which raises an uncomfortable question, one this documentary has been building toward from its very first seconds. What happens when the world's greatest survivor finally runs into a set of conditions it cannot outlast?
For an enormous stretch of time, Homo erectus effectively had the human world to itself, the only human lineage spread this widely across this many continents. That eventually changed. Human evolution has never been a straight line, a single ladder with one species neatly replacing the last. It's closer to a branching, sometimes tangled tree, with multiple human populations frequently existing at the same time, sometimes in the same regions. As the story moves forward, other human lineages begin to emerge and spread, including later populations ancestral to groups like Neanderthals in the West, and eventually, much later still, our own species, Homo sapiens, arising in Africa.
The details of exactly how these populations interacted with surviving Homo erectus groups, competition for territory and resources, avoidance, or simply not overlapping much at all in certain regions, remain genuinely unclear and vary a great deal by region and time period. This isn't a case where scientists are hiding a known answer. It's a case where the evidence itself is thin and scattered. What can be said is this: the world Homo erectus had once had largely to itself was slowly becoming more crowded with other kinds of humans, ones carrying different tools, potentially different social strategies, and adaptations shaped by different, often harsher environments. Homo erectus had already outlasted droughts, ice ages, unfamiliar continents, generations of predators. Now it was entering, whether directly or indirectly, one of the strangest tests any species in this story has faced: sharing a planet with other humans.
The final chapter of this story takes place far from where it began, not in Africa, but on the island of Java in Southeast Asia. At a site called Ngandong, along the banks of the Solo River, researchers have recovered a cluster of Homo erectus skulls that represent some of the youngest examples of the species found anywhere on Earth. Dating fossils this old is difficult and contested. Different studies applying different methods have proposed a range of ages, and the scientific debate over exactly how late this population survived is ongoing. What most researchers agree on is that Ngandong likely represents one of the final chapters of Homo erectus as a distinct population, possibly persisting long after related populations elsewhere in Africa and mainland Asia had already disappeared.
Picture that landscape, a river valley in the tropics, forests and grasslands shifting with monsoon seasons, an ecosystem in flux as the surrounding climate and animal populations changed. A population that had once been part of a much wider, connected story, growing more isolated on an island as time went on. Why, in the end, did they disappear?
There isn't one confirmed answer, and any documentary claiming otherwise would be misleading you. What researchers point to instead is a set of plausible, overlapping pressures: shifting climate and habitat conditions in the region, changes in the animal communities they depended on, the vulnerabilities that come with a small, increasingly isolated population, and possibly, indirectly, the arrival of other human groups nearby. Most likely, it wasn't any single dramatic event. It was probably a slow accumulation of pressures, the kind that can end even a survivor's story. Not with one catastrophe,
but with a landscape that kept changing, until eventually, in that particular corner of the world, adaptation ran out of room. The mystery, honestly, remains open. And maybe it should stay that way. Not every question in this story has an answer yet.
Step back now and look at the whole shape of this story. Homo erectus was never the strongest predator on the landscape, never the fastest, never armed with anything close to what later humans would develop. By some measures of intelligence, later human species likely surpassed them. And yet, they outlasted nearly everything the world threw at them, for a span of time that dwarfs every empire, every civilization, every era of recorded history combined.
How researchers understand the relationship between Homo erectus and later humans, including our own species, is still an area of active, sometimes contentious research. Questions of direct ancestry versus more distant relation are far from fully settled and vary depending on the region and population in question. What is far less disputed is this: whatever the precise family tree looks like, Homo erectus represents one of the most significant chapters in the story of what a human being can be, long before anyone who looked like us ever existed. So return, finally, to the question this film opened with. How did they survive for so long? Not by conquering their environment, not because life was ever easy for them, it almost certainly wasn't, not because they had some singular advantage no other species possessed.
They survived because generation after generation, when the world around them changed, they changed how they lived in it. They walked further. They built tools that worked and kept using them. They may have learned to hold on to fire. They cared, in whatever limited way the evidence allows us to say, for each other. And when even that eventually wasn't enough, in one river valley, on one island, after nearly 2 million years, the story finally closed, long before cities, long before writing or agriculture, or anything we would recognize as civilization, long before our own species had even taken its first breath. Another kind of human had already discovered one of the oldest rules any living thing has ever learned. The world does not promise to stay the same.
And the ones who last in the end are simply the ones who learn how to change with it.